Thank you for joining us today in this beautiful morning, and also a special thanks for three of our judges for your time in this event. My name is Ryan, and I will be your master of ceremony this event. Next, we'll hear a presentation from Azhar Unisi from Universitas Islam Indonesia. For the team, while we're waiting for the team, we'll have to remind you again that we have 7 minutes for presentation, and also 8 minutes for question and answer session. The time will be shown in the screen. Welcome to Team Azhar Unisi from Universitas Islam Indonesia.
Okay, we can put that.
Okay. Sorry. Well, the rule is simple. We have 7 minutes, and 7 minutes only for the presentation. And the session will be continued with 8 minutes question and answer session. The time will be shown in the screen right here. If you have any questions so far? So far is good. You ready for the presentation? Panelists ready for the presentation? For the either missing the wall.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It's a great honor to be here for presenting our card. My name is Tiara Habibajida as a member, Ms. Farida Ilyas as a member, and Mr. Akram Prawira Negara and this is our supervisor. Presentation outlines: first, about the team, second, assembly process, third, model of car, and last, economy aspect. Fossil fuels or fossil energy are the most widely used fossil fuels in the world community. It results in higher demand in production, causing scarcity. Chemical is car designed to move using the result of chemical reaction. This is the could be used in future as alternative in reducing the use of fossil fuels. Azhar 01 is a car that uses electrical energy generated by DC, with the working principle of temperature difference between the two sides of the tube. Azhar 01 has a body made of PCB board. Assembly process: first, looking for energy source. Second, measuring the amount of energy. Third, determining of the DC motors used. Fourth, Next, my friend Farida would like to explain the body of car.
Okay, thank you. This is part of our car. This is valve to insert chemical materials. This is cooling tower and integration reaction. This is helping to give a code of PEC. This is when it's supposed to bring a stream of chemical reaction. This is reaction as a place to chemical reaction. This is PEC to as a generated electricity. This is fuel. This is exhaust to the reaction gas. This is stop mechanism. Azer 01 has an empty source silicon reaction head of sodium hydroxide plus water with aluminum reaction. This is reaction. The reaction products of natrium and NiOH is processed into iron by adding acid sulfur.
There is a safety mechanism. There is a cooling tower. The cooling tower is a tool is very because the tool is to be safety mechanism and environmental aspect, because the tool have to anticipation the burn the hydrogen gas and to safety the sodium tetrahydroxide element to out with gas. In stopping mechanism, have two parts. One part for sodium hydroxide solution tank and in this bottom is aluminum bar. The working principle of stopping mechanism, the aluminum bar can be reaction with the NaOH, that sodium hydroxide, to degradation the aluminum bar and finally the bar will be break and fall and the cut will cut the electrical circuit and car will be stopped. Is graphic of experiment of stopping mechanism. Yes, economic aspect. Thank you.
Time, and then next to complete the question and answer session to our panelists, please you may come.
Alright. I think I will start first. Congratulations for the you see for Azhar 01. Alright. I do believe that you have to do the thorough literature review or from the YouTube whatever about the concept and also the technology
mechanism in this car have is different from another chemical because the principle of the stopping mechanism is low cost and is simple.
So it's only a stopping mechanism, but the aluminum rod is basically the normal.
And if the chemical reaction have a special because the product of the reaction of chemical reaction have been explored have all about product of chemical reaction can be explored with natrium yang aluminium hydroxide aluminium tetrahydro alumate can be make alum can be to edited the can be edited heat
Producing the heat, right? Your reaction basically producing heat. Yeah, is it right or not?
No. Jadi
No, right?
No.
For the stopping mechanism, I think they want to mention that aluminum can be used just adding sulfuric acid,
Are you
right?
still talking about stopping mechanism? Or not the reaction?
but the reaction
Okay.
Oh, what do they
Okay,
say?
the
Okay,
reaction.
direction. Okay.
reaction the all of but product and hydrogen gas can be generated the energy with a fuel cell and the sodium tetrahydroalumate can be used to be alum can to edit the sulfur acid.
Alright, thank you for the answer. I think maybe
Okay. In Indonesia, it's okay? Oke ya. Saya bertanya pakai bahasa Indonesia aja daripada nanti kamu kesulitan, ya. Kiranya masih harus menyampaikan. Oke, saya melihat dari sisi safety-nya dari proses ini bisa dijelaskan nggak dengan menunjukkan di mobil ini, coba. Prosesnya bagaimana? Dari keluarnya gas H2. Karena kamu menyebutkan di sini adalah faktor yang berbahaya adalah flammability. Karena dia adalah mudah terbakar karena di gas H2-nya. Oke, saya ingin tunjukkan gas H2 tadi prosesnya gimana? Coba. Keluarnya dari mana, ininya bagaimana? Kamu jelaskan. Silakan. Yang tengah tadi belum menjelaskan, silakan. Ya, prosesnya di alat ini di mobil ini seperti apa? Bisa keluarnya gas H2 tadi.
Gas H2-nya itu keluar dari sini dan di dalam sini heatsink, di sini ada heatsink yang di sini tuh
Bisa dibalikkan di sini biar saya bisa melihatnya. Oke.
jadi di sini ada heatsink sama sini ada heatsink. Lalu di yang kotak di bawah ini di sini tuh ada selang ini untuk keluarin H2X. Lalu jadi gas yang didapat dari kulit power ini dikeluarkan dari
Oke. Anda tahu itu flammability itu dari apa?
itu dari reaksinya.
Reaksinya. Pada saat Anda jalankan, Anda harusnya tahu dong. Anda memberikan di MSDS NFPA di situ Anda tulis 4 karena itu flammability 4 itu paling tinggi. Bagaimana Anda bisa mendeklar kalau itu tadi Anda juga tulis di sini di CSA itu adalah flammability, tapi Anda tidak di sini tidak menjelaskan kok bisa flammability itu dari apanya? Pada saat proses itu terjadi pastinya tahu dong.
Flammability yang terjadi itu ketika dia gas hidrogennya ini kami membuat exhaustnya ini agak panjang ke atas agar distance menimbulkan percikan listrik.
Oke, semuanya pasti akan di dalam bilang seperti itu. Ada keluar percikan apinya. Oke. Terus kontrolnya kalau memang menurut teori itu keluar percikan api, apa kontrolnya? Kan ada hazard control. Untuk hazard controlnya dari flammability.
Jadi karena reaktor ini untuk mengantisipasi agar karena gas hidrogen yang paling banyak ada di reaktor, jadi kami menggunakan ini nanti diisi air setengah. Ketika gas hidrogennya ini berlangsung, ketika ada kebakaran, dia nggak akan langsung ke reaktor. Jadi untuk flammability yang lebih besar, dia akan cenderung untuk turun.
Iya, namanya kamu kasih kontrol apa nih? Entah itu pressure-nya dari sana atau flow control-nya atau apa? Yang kamu kasih apa?
Pembatas antara gas hidrogen yang ada di sini sama
Pembatas saja.
Pembatas
Dari yang dari selangnya aja.
Iya, dari pembatas dari ketika kita bakar di sini, dia nggak ikut ke api yang ada di sini nggak ikut ke dalam reaktor.
Tapi sudah seperti itu. Itu dari flow-nya berapa dia bisa keluar di ujung sini?
Flow dari hidrogen ya?
Iya, dari sana kan dari reaktor tuh habis itu untuk keluar sini kan tadi katanya kamu masih pembatas. Maksudnya kan kamu ada perhitungannya. Belum. Oke, kalau gitu. Oke, silakan Pak.
Oke, satu pertanyaan sampai beda temperaturnya jadi berapa?
Beda temperatur. Jadi kami menggunakan ICECC.
Yeah, so basically you need to make sure during the race that the temperature is relatively high in order to make sure your car continuously moving because EEG will not work at all. Boleh jawab pakai bahasa Indonesia?
Perbedaan temperaturnya itu dari reaktornya sendiri yang bagian bawah ini. Ini
itu berapa?
Ya.
Ini sekitar sampai 90 derajat.
Oke.
Kuning.
Kalau coolingnya mulai dari 2,5 hingga 2,5.
ICECC.
So almost 80.
Iya, nggak tahu sih.
Okay. But be sure because in the race area,
So
the temperature is relatively high.
Yeah, very high, you know. So this is
So I don't think
control
it's
system.
different.
Have you tried using the what you call it, the CO2 ice?
Nah,
Ya.
nah.
Dry ice.
Dry ice.
Dry ice. Have you
Dry
tried
ice.
using
Sudah
dry
pernah
ice?
dicoba belum?
Untuk dry ice kami belum mencoba karena salah satu pembuat dari dry ice itu CO2, jadi belum ada, jadi kami mengurangi gas emisinya, jadi kami nggak menggunakan dry ice itu karena untuk nanti ada penanggulangan buat CO2 nya lagi untuk supaya nggak keluar di
Let me try it.
Okay.
Strategy.
Thank you.
Thank you.
The time is actually over. So thank you very much for the meeting. You may proceed to the inspection table with your car, just right next to the registration table. Yeah. Thank you very much for joining us. Sorry. Yeah. Okay. Thank you very much.
I think we don't need to use this.
Yeah. I don't think
Okay.
we need
Yeah.
this one.
And also
Yeah.
what is
Bersama kami, berjuang dan terus berjuang karena Good morning, ladies and gentlemen. We are from
Surabaya 3.0.
Polytechnic Negeri, and today I will go into tell you about our prototype car from Supernova 3.0. And let me introduce myself first. My name is Safira as a speaker, and we had our team members. There's Denny as a leader, Adit as a power source analyst, myself as a stopping analyst, Doni as mechanical analyst, and Jeffrey as electrical analyst. Before start, I would like to ask you one question. Have you ever heard about Seebeck Peltier effect? The Peltier effect is the process of heating or cooling from two different conductors. Meanwhile, the Seebeck effect is the effect that conversion of heat directly into electricity within two different wires. Why is this two effect is important? Because this two effect is linked to a thermoelectrical system that we use in our car. So we start from our car design. As you can see, our car design is followed by based on the F1 car design. We follow it very detailedly. You can see many similarities for the rear wing, the front wing, the body also, and the wheel. And this part is our reactor. This is where we put the reaction for the power source. And this side is our stopping mechanism bottle, and we put the electrical side under the spoiler. For our car concept, this consists of three important parts. There's the chemical parts, electrical parts, and mechanical parts. For the chemical parts, we use the very simple compounds. For the power source, we use the reaction between calcium oxide and water, plus the mixture between ice cubes and sodium chloride. And for the stopping mechanism, we use the reaction of aluminum by sodium hydroxide. And for the electrical, the power source side, we use the temperature differences being converted into an electric voltage. And for the stopping mechanism, we use the photodynamic sensor. And for the mechanical, as I said before, we followed the F1 car design and very detailedly. This is our car energy conversion. So there's a chemical reaction. It will be converted into electricity by the thermoelectric system, and then thermoelectric produces 10 volts, and it will make the car to move forward by a powerful mechanical. This is our sketch for our container design. It consists of two parts. There's a whole container. This part is where we put the ice and a bit of water with sodium chloride, and the lower part is a heat container. This is the place that we put the calcium oxide and water reaction, and the reaction can be seen like this. And this, the pressure work goes by creating temperature differences by its two surfaces. So the upper surface has a cold temperature, and the lower surfaces has a heat temperature. So there will be a different temperature that this differences is converted into electricity by this culture. And our stopping mechanism, we use the reaction between aluminum and sodium hydroxide that it will produce a black color, but in the form of dissolved suspension. And we use the photodiode sensor. And the reaction for the stopping mechanism can be seen like this. This is our chart for our stopping mechanism. So this is a relation between time and aluminum weight. So if we use the heavier aluminum weight, then the reaction of the stopping mechanism will go faster than if we use the lighter aluminum weight. So, and we had ideal linearity because it's almost to 1. And this is our sensor work. So our stopping mechanism sensor is goes by we put the bundle between the infrared LED and the photodiode sensor. So the LED will emit the light to photodiode sensor, and it will be blocked by the solution. And when it's blocked, then it will cut the electricity and it will turn on the relay contact. That means the motor DC is inactive, so that's make the car will stop automatically. And this is for our mechanical concept. We use the acrylic head of 5 millimeter thickness. For the power source, we use the heat resistant by polypropylene, and for the stopping, we use the perfume bottle. And our motor requires 3 until 12 volts, which can run up to 100 RPM. This is our economical aspect. So our calcium oxide and stopping mechanism quite cheap for one run. This is our cost for one run. So that's all for our team. Thank you for your attention, and I hope you enjoy your presentation. Good morning.
Okay. Okay, quick question. The first one is EG price. You didn't mention about the EG price. The second one, the sportive, the thermal electrical generator for moving your car. It's based on thermal electric, right? Yeah. But the price of thermal electric sensor itself, they're cheap. That's the reactor. Okay. You made a very sporty car, aerodynamic, so it will be useful only for higher speed. Please let me know your actual speed, and then during the race there will be a load put on the top of it, around 10 to 20%. How can you manage that one? And the last one is related with you tested it in Bandung, right, where the ambient temperature is much different compared with Surabaya. So how about that? Thank you.
Our car velocity is about 0.352 meter per second, and we also tested by load 20% of it, and it still runs until the end.
So you don't need aerodynamic for 0.3?
No, we only use it for detail.
Next.
Detail design.
Yeah. What else? About the temperature. What is the temperature difference then in Bandung? Because you use ice, it's relatively around 2 degrees in Bandung.
I think it's not really different because we use the copper,
Okay.
and we.
But the ice cube is on the top, right?
Yes.
And you don't use any cold insulation. You only use heat insulation for the bottom part.
Yes.
So please be careful during the race.
Okay.
Okay, and the last one about the slurry, sodium aluminate as slurry. It will be the stopping mechanism, right? How if it ended sedimented, not becoming a slurry, not in a suspension state?
Coming.
When it starts to form sodium aluminate, and it's completely grounded, completely sedimented.
Oh, actually, the time when it'll be sedimented is too long.
Okay.
Yeah, had a long time to sediment it. So this version still be good.
But you don't know the length of the race, right?
Yes.
So please make sure during the race it will not eventually sediment. Okay, thank you.
Okay. Yeah, you don't know that. Okay, can you explain to me about the process, this one, and then show me how the H2 gases is flow and like the Mr. Ari said that high speed, and then it can be sedimented. Please.
So this bottle is for the stopping mechanism, and then we put the aluminum here in the form of tiny balls, and we pour the sodium hydroxide solution, and we put this hose to ice reactor because the gas will be flowing to here, and it works like
For more lower temperature in here.
Yes.
Yes. Okay.
So the gas will flow in here, and this is work like scrubbing system.
Okay.
So the gas will be trapped in this container.
Okay. Have you identified the hazard from the this one, reactor, and then before they into the nose and then the dry ice?
Identify the gas.
Identify the gas. The hazard. Identify the process from there and then decide.
Yes, the gas will.
Please, you can explain. Identify what the hazard.
So
from that process, okay?
yes, this aluminum oil.
Look at me.
Sorry. And then this is sodium hydroxide solution.
Yeah, identify the hazard. I just want you to identify the hazard. You can identify the hazard. Not you, okay? You. Okay, identify the hazard.
When the reaction is the solid about the aluminum will be reactive, but it produces the H2 gas. So
what hazard then?
what is
Oh, it's makes
Physical or chemical hazard? What kind of hazard?
I think it's a chemical hazard.
Chemical hazard, okay.
Because it's produced H2, which is we can make our asphyxia.
Okay, how you control it?
We flow it through the this container.
Okay.
So the gas will not be outside, and it trapped to.
How to ensure that?
Because when we try it, the gas is flowing through here, and there's no gas outside.
If there's a leak, what do you want? What do you do if there's a leak in that nose?
A leak from this hose.
Ya. Kalau ada kebocoran, apa yang Anda lakukan?
I don't think it's fully insulated, right?
Nah, itu
It's not
masalahnya.
insulated.
Yeah, that's the point, sir. That's
The
point.
black box basically is
Yeah.
It's open. It's not fully insulated.
There's always a leak there.
Yeah, there is still have
Still
a
this
space
there, okay. Okay.
where the gas can transfer.
Okay,
Okay, the last one, the simple question: how where did you put the load?
Put the load in
Yeah. In front end.
On the top of it.
we try it in the front.
You put it over there.
Yes.
And
But there is a slope there.
Yeah.
It's not completely flat.
Because your design is aerodynamic like a F1 car,
Yeah.
but you need to know the objective of this chemical is not for the speed.
Speed, yeah.
It's not for the speed.
Yes.
It's how do you handle the load and also to stop at the specific distance.
Yes.
Right? So you still have a time to think about how do you put the load because this is very slow. This is not balanced. I'm afraid that the load will be is not stable over there. Okay? Alright. By the way, it's a very good design.
Thank you. Thank you very much for Team Supernova 3.0. Right now you can proceed to your car.
Last year 2.0, right?
Yeah.
Next year 4.0.
Continuously improving.
Yeah.
Still have a lot of numbers.
Okay.
So, Team Supernova 3.0, you can proceed to the inspection table. right next to the registration.
Like all the best.
Hope for this. Thank you very much.
But nice design.
Design, but not
But not on
selfie.
purpose.
Purpose. No.
They don't think about it.
So that's why I want to explain the hazard. You have to mention the hazard. So they must be for approval and grandfather.
Welcome to Line 4.0. You can put the car over here. You can stay over here. And please keep the screen visible. Okay? All of you can stay over here. Alright. So team Line 4.0, we have Dr. Ahmad Kamarudin, Miss Aileen, and Dr. Hari on the panel. And the rules simple. You have 7 minutes and 7 minutes only for presentation, and then we'll continue with 8-minute question and answer session. You have a whiteboard if you need something to write down. For the Line 4.0, are you ready? Okay. Ready? For our panels, are we ready?
Okay.
All right. So for team Line 4.0, we will choose.
Good morning, judges. Institut Teknologi Bandung presents Black 4.0. I am Bonar as the team leader, and I have Faisal and Haris as my crew, and I am Anas as our manager, and our advisor is Mr. Widya Atmoko. So the presentation today will be started with the explanation of our car features, followed by the construction, and then power source, stopping mechanism, environmental and safety aspect, economical aspect, and ended with the strategy to reach our goal. So, first, let us introduce with our little friend here. Our car power source comes from the electrochemical reaction. The reaction comes from the aluminum and air battery. What actually makes our car unique? Our car is simple. And I want to introduce you to our main feature. There are gearbox and mechanical motor at the front side, and there are chemical container at the back side. There are also battery container, then chassis, and then the Arduino. The construction process starts by the cutting of the chassis. The chassis was made from the acrylic, and its size is 34 by 22 centimeters. Then we choose polypropylene as our material for the battery containers. The battery container is not closed to ensure there are sufficient oxygen for the reaction in the battery. Why we choose polypropylene? Because the polypropylene is easily found in the kitchen as any container, and its ability to handle strong acid and base, and then it is easy to make from the used container. Battery construction process is started by cutting the aluminum into plates. The aluminum will act as the anode. And for the cathode, we use the carbon collector as the base, and we spread carbon all over this both sides of the carbon collector, and we'll cover it with tissue membrane, and we'll clip it by one. And it's the front view of our battery, and this one is the side.
So this is our power source, aluminum carbon reaction. In anode, aluminum will be oxidized, and in cathode, oxygen will be reduced. This is our power source liquid with potassium hydroxide solution in this membrane. And aluminum will be oxidized to aluminum ion with 12 electrons, and 12 electrons will be react with oxygen to hydroxide ion, and hydroxide ion will be react with aluminum, become to aluminum hydroxide later on surface of aluminum. And aluminum hydroxide will be slow down of oxidation reaction. And this our reaction with potential reaction 2.064. Okay, this is our stopping mechanism. Our stopping mechanism is start with hydrochloric solution. Our stopping mechanism is aluminum glucose solution. Aluminum will be react with hydrochloric solution when the aluminum is dissolved with hydrochloric solution. Arduino will be cut the current to dynamo. Not only simple, our equipment is eco-friendly. Our battery will be made from waste material like waste aluminum container and foil, and from carbon active from carbon for aquarium and UV resin. And our car is safe because our waste is just potassium hydroxide and hydrochloric solution, and this material is neutralize each other.
Okay, and then this is the economic aspect, and this is the capital expenditure, and here are all the materials that is needed to create our car, and this is the total cost. It will be 125, and then sorry. So we can also use waste material for our car, such as the carbon, and the aluminum for the waste. And by doing so, we will reduce the total cost almost 20%, and it will be just 103,000 rupiah. And then this is the optional expenditure, and we will need 5,100 rupiah per run. And the aluminum can be used more than once by removing the aluminum hydroxide using abrasive paper, or we call it ambas. So this is the strategy to score our goal, and by arranging the battery into parallel configuration, we can acquire higher electric current by inner voltage, and we also produce torque for a relatively constant velocity. And we also create this curve calibration of hydrochloric concentration with respect to time, so we can determine the hydrochloric concentration that is needed for a certain amount of time until the reaction stops because of corrosion.
That was the end of our presentation. Thank you for your attention.
Thank you, Plan 4.0. So this is extension from the 3.0 last year, right?
Yes.
Yes. Nice. Alright, the fourth series. Okay, the fourth versions. Alright, so I'm looking at the innovation and also the design aspect from the 4.0 compared to the 3.0. Alright, so can you explain that in very brief? Because we had still a lot of questions in the class, right? So what's the difference between 3.0 and 4.0? Alright.
Okay, for the Blink 4.0, we will not use Kalha solution in the inside of the container. Instead of that, we will input comma with the serine into the membrane directly, because with our investigation, the causal solution will make some big resistance in the current, so we will use the
Syringe.
step.
So there will be no issue for spill as well.
Yes, that's the point.
Is that happened last year?
No, that not happened last
But
year.
you prevent it.
Yes.
Right.
Kompak sekali ya.
And then you have the last part of your presentation is how to achieve the goals, and basically just how you get the power. But you know what is basically the objective of this competition? You need to bring some of the load,
Yes.
okay, and come to the stop at the specific distance.
Yes.
So you have some hurdle in between.
Yeah.
Right? So where do you put the load? Okay.
The load.
Oh,
The water.
You need to put the load. Where?
Where is
Where is
it?
it? I think the load will be placed on the
Top
top
of the
container.
container.
Container and then?
And then we will
Yeah, that's container.
use some isolate tape to make the base.
To stick
stick
the load
the load.
on top of the hydrochloric container.
But not the black one. Is that is only for that container, right? No, the black tape.
The black tape. Yeah.
Oh,
No. Top of the container.
yeah.
Yeah.
Not that one, right? That is for you to seal the container, right?
No, it's not to seal. It is for make the cable stick on
Stick on the container.
Oh,
That's
okay.
Because there is a cable under it.
Yes, that's it.
Oh,
But
alright.
how can you make sure there will be no standing issue? Because if it is too heavy, I don't think it will be flat.
I don't know.
Have you tried with the load?
Yeah. Have you tried with load? 20% of your total car weight.
Not yet. Not yet.
Okay. Is there any heat exposure when the car was operating?
No, there are.
There. In what speed? Maybe for 4 meter per second.
The
or-
velocity.
Yeah.
So based on
The
our
speed, for the speed,
The speed.
the highest speed that you tested for this car for blank 4.0, for the high speeds, how?
if I'm not mistaken, the highest speed is around 0.2 meter per second. The top speed.
0.2
2 meter per second.
Per second.
But the average velocity is just 1.5 meter per
How long
second.
distance that you can reach for that speed?
The distance, the maximum distance will be 80 meter. 80 meter.
It is without the stopping mechanism.
Mm.
So it's longer than 3 minutes.
Longer than 3 minutes.
But the battery can stay go
Until the 80 meter.
Okay. The HCl KOH-nya tadi dengan distance 60 meter, ya. Itu dia menghasilkan berapa? Waste-nya tadi kan ada spill tuh, spillnya is okay karena udah denaturalize, ya kan? Nah, waste-nya tadi yang Anda sebutkan di sini karena tadi Anda menyebutkan adalah KOH dan HCl-nya, ya. Itu dengan segitu tuh berapa ininya waste-nya?
Untuk pelayanan sendiri kami mempersiapkannya sekitar 200 mili dengan konsentrasi tertentu. Tapi kan yang digunakan di dalam baterai itu kan hanya sedikit aja Bu. Nah, sedangkan HCl-nya masih berat
Sekitar 20 sampai 30 mili. Jadi kalau misalnya total dari waste-nya itu sekitar 30 milian. Jadi kalau yang untuk KOH itu kami kan pakai series. Jadi hanya sedikit untuk KOH-nya. Jadi waste-nya itu lebih banyak di HCl.
Lebih banyak HCl-nya.
Yes.
Oke. Berapa persen?
Maksudnya konsentrasi atau
Iya,
jumlah?
konsentrasi. BPM-nya?
Jadi, kalau
Satu?
untuk HCl itu kami tergantung dari jaraknya.
Semakin besar, maka dia akan semakin besar konsentrasinya.
Konsentrasinya, ya.
Oke.
Jadi dari grafik yang tadi kami tampilkan itu kan jarak waktu terhadap konsentrasi. Nah itu nanti kami sesuaikan di lapangan.
Oke. Can you identify the hazard dari proses yang tadi?
Define the hazard.
Iya. Bisa nggak di list di situ? Define the hazard.
Hazard
During the process, ya.
Just like this, what is your potential hazard during the process?
There are maybe short circuit if we don't press the battery correctly, and then
You have a HCl with what is the concentration of HCl that you use?
one molar.
1 molar.
1 molar.
1 mole.
Maximum.
Maximum.
The same with also with the KOH. 1 molar also.
KOH also 1 molar.
The KOH is about 10% weight.
Yes, equal 1 with 1 molar solution. Yes.
Pernah ada uapnya, fume-nya nggak?
Sejauh ini enggak. Untuk yang tahun ini tuh kami memodifikasi struktur dari baterainya. Nah yang dari tahun kemarin itu banyak uap hidrogennya.
Nah itu yang
Ya.
saya ini kan,
Ya.
karena kan ada hidrogennya. Makanya saya tanya, ada uapnya konsentrasinya yang mana itu? Coba ditulis aja nggak apa-apa. Ada menulis yang identify dengan.
Yang tahun ini, untuk yang tahun ini selama percobaan kami tidak ada uapnya. Karena konfigurasinya konstruksi baterainya sudah berubah. Yang kemarin itu lebih banyak karbon aktifnya sehingga reaksinya itu cepat. Sedangkan yang kami itu sekarang lebih mengarah pada konsistensi kecepatannya. Jadi walaupun lambat tapi konsisten. Nah, sehingga si hidrogen ini berjalannya reaksi hidrogennya tidak terlalu cepat sehingga dinamo itu menarik arusnya lebih konstan sehingga tidak ada uap yang terbentuk. Apabila reaksinya terlalu cepat seperti tahun kemarin, dinamonya narik arus tapi reaksinya terlalu cepat sehingga akhirnya ada reaksi samping yaitu perpasan hidrogen.
So hydrogen is not the main, during the main reaction occur, the hydrogen will not occur. Only for a side reaction.
Yes.
So
Okay.
I'll have to remind you that the time.
Yeah, last question. What is the purpose of Arduino?
Sorry?
Purpose of using Arduino? You don't need Arduino basically if you use